We will now start our study of modes based on the major scale, using the major scale as a parent scale, so we will derive the other modes from the major scale. And the major scale is also our first mode, which is the Ionian mode. So first I'll just go through an overview of our Python code. Later on other tutorials I'll go step by step, line by line, discussing each method, each function, each class used. And here we will have a chance to take a look at the Ionian scale or the major scale before we start deriving the modes. So I decided not to use the major scale in C. So usually when we study modes, we take the major C scale and then we derive the second mode starting from the D, then we derive the third mode starting from the E, and so on. But I've noticed that a lot of people, they get confused, because what is important is not which note we are using to start. What is important is the intervals that are present in different sequences when we start in different places. It will become more clear when we start deriving our modes, but first let's do some revision about the major scale, the intervals present in the major scale, and some Python code. So first what I'm doing is I am using this class major scale, and I'm creating a F-sharp major scale, so we are using a computer, so we can get very complicated with our notes and scales. It will compute everything for us, but it's also a good exercise to do it by hand. So then I have a F-sharp major scale object here. I'm creating a string, so we will use strings to create musical scores. Then we will have something like this, for example. Then I'm adding a key to this string. So I'm defining a key with this class, it's in the F-sharp key, and then I'm inserting this key in this string. And now I want to get the notes of the major scale object that I created here. So from this object we can get the pitches, and then I can construct notes from these pitches. We will talk about pitches, notes, scales in detail. For now it's just an overview of what I am doing. So I'm creating a list with notes, and these notes use the pitches of the F-sharp major scale. Then I am getting the intervals between these notes. So from this F-sharp major scale object I can get some intervals, and these intervals, they are what I'm calling here consecutive intervals, or intervals between the notes. I can also get the semitones from these consecutive intervals, and then I will have how many semitones are in between each note. Then I'm doing a cumulative sum of these consecutive semitones, because I'm going to use these consecutive semitones to get the intervals of our Ionian scale or major scale, but in terms of perfect first, or our root, major second, major third, perfect fourth, and so on. Finally, I am creating this musical notation score here. I'm printing that it's a F major or F Ionian. I'm adding here these lines to have the names of the notes, to have the intervals, to have the semitones, and to have the intervals between each note. So this is the F-sharp major. Here are all the notes that are present in the F-sharp major. So we have an F-sharp, a G-sharp, an A-sharp, a B, C-sharp, D-sharp, E-sharp, and back to F-sharp in another octave. So we have perfect first, the major second, a major third, a perfect fourth, a perfect fifth, a major sixth, a major seventh, and a perfect eighth. So what does it mean in terms of semitones? From the root to the major second, we have 2 semitones or a full tone. From the major second to the major third, we have 2 semitones again. Then we have from the major third to the perfect fourth, we have just 1 semitone. So now we have tone, tone, semitone. Now from the perfect fourth to the perfect fifth, we have 2 semitones. From the perfect fifth to the major sixth, 2 semitones. From the major sixth to the major seventh, 2 semitones. And from the major seventh to the perfect eighth, we have 1 semitone. So it's tone, tone, semitone, tone, 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 semitone. And here we have these relative intervals between each note. So here they are all relative to the root. So this is the major third relative to the root, the perfect fourth relative to the root. But now from the root to the major second, we have a major second interval. From the major seventh to the major third, we have a major second interval. Major third to the perfect fourth, we have a minor second interval. Perfect fourth to the perfect fifth, we have a major second interval. Perfect fifth to major sixth, a major second. Major sixth to major second, a major second. And finally from the major seventh to the octave, we have a minor second. And this we can see this tone, tone, semitone, tone, 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 semitone, or half tone. In certain literature, we can also say tones and half tones, or tones and semitones. So this is our major scale, and this is what's important. We know that the major scale, it has, for example, a major third, and this defines this scale as a major scale. We have here the major 7, and the important is to notice that we have a half tone between the major 7 and the perfect 8, and a half tone between the major third and the perfect fourth. Here we can see that we have a problem. Here I am printing the F sharp major scale, which is here. Then I am calling the show to this stream, and this gives me this nice musical notation here with a staff and a cliff and the notes. Here I'm having this that I am displaying as if it would be lyrics in a song, but I'm putting names of notes and intervals in this part here. And then I am calling the show method to show as MIDI, so we could hear, but nothing is showing up. So this is a common problem in Google Colab. So Google Colab is a great environment. There are a lot of things that are pre-installed, but it's dynamic. Things change, libraries update, they upgrade, and sometimes we have these different versions of libraries that are not working properly. So what we need to do in this case is I will upgrade the Music 21. So I'm pip installing upgrade Music 21. Let's run this. Here you see that it found the Music 21 8.1.0. It's uninstalling, and now it's installing the 8.3.0. Now let's rerun the code. And now we have here this MIDI player that will play these notes here. Have in mind that if you may have to disconnect, delete runtime, reconnect and install everything again if it's not showing straight after you just install, because maybe the old version is still running in the memory and not loaded the new version or something like that. So let's listen to the major scale or the Ionian. once again. And what is very important to have in mind is this specific interval relations, so that we have here one semitone and also here one semitone, and then we have whole step, half step, whole step, whole step, whole step, half step. So there are many different ways how we can phrase it, using tones, semitones, steps, half tones. It doesn't really matter. What is important is to see that we have one semitone between the major third and the perfect fourth, and one semitone between the major 7 and the perfect 8. So it doesn't matter which key we are, this interval will be always the same. And just to prove it, let's go to, for example, B flat. So now I will be in the key of B flat. Here I just need to print B flat instead of A major. It's just a printing. Okay, now we have the B major, B flat major, or B flat Ionian. And we see here that between the major third and the perfect fourth we have one semitone or a minor second interval, and here between the major 7 and the perfect 8 we have one semitone or a minor second. And let's see how, let's listen to it. So now we have our major scale. We understand how to build a major scale. So what we do, we take a root, then we add 2 semitones, we get the next note, 2 more semitones, we get the next note, 1 semitone, we get the next note, 2 semitones, 2 semitones, 2 semitones, and 1 semitone, and we have this sequence of notes that forms this scale. Or we take the root, then we calculate a major second, a major third, a perfect fourth, a perfect fifth, a major 6, a major 7. With this information, this relation between different notes, these intervals between notes, we can construct, we can build any major scale that we want. So next, what we'll do is that instead of having the root here, so suppose we bring this note up here and we start from this here, and this will be our root, and then we will calculate which interval is here, which interval is here, which interval is here, and then we will get our second mode, which will be the Dorian mode. But before we move to deriving the Dorian mode from the major scale, we will go into the Python code used here.